Hello friends, we'll continue the lubrication and bearings chapter. So let us go for the meaning of viscosity, because the viscosity is the main property which is going to be used for calculation of all the parameters necessary to design the journal bearing, as well as to calculate the heat loss as well as temperature rise in journal bearings. Okay. Now viscosity, it is the ability of a fluid to resist the change in shape. So this resistance is due to the internal friction and its molecular phenomena. Okay. Now the load carrying capacity is depends on the viscosity. Okay. Now as the fluid resists the flow, and work is done here. Okay. So work is going to be done on fluid. Okay. So now this work is done, is converted into heat because of the resistance or because of the friction, converted into heat. Now as the work done is converted into heat, so the surrounding temperature is going to rise. Surrounding temperature is going to rise. Okay. Now as you've seen, you're going to get different types of viscosity. That is what absolute viscosity and dynamic viscosity, and both are same here. And there are two types of viscosity are kinematic viscosity and relative viscosity. So now especially in design of this journal bearing, so these are the two main properties, that is what absolute viscosity and dynamic viscosity and kinematic viscosity. Okay. Now this absolute viscosity may be defined as force required in a plane surface having a unit area or another plate with unit velocity, separating the plates by unit thickness of fluid layer. That is what it's defined as the force required in a plane surface. Now if you consider a plane surface, one plane surface of unit area, okay, or another plate. So now I'm going to draw one more plate here exactly below, or another plate. Okay. Now this is the force required, that is what F. Okay. With the unit velocity. Okay, now you have a fluid between these two plates here, which is of a unit velocity. That is what V. Now thickness of this fluid medium is what H. This is also unit thickness. Okay. This is also what unit thickness of fluid layer. Now according to Newton's law of viscous flow, the shear stress in the fluid, that is what the shear stress or shear strength in the fluid is directly proportional to the change of velocity. Change of velocity or velocity gradient or rate of shear. That is what, if the velocity is more, the sliding will be more, then you are going to get a more frictional force. Okay, if the velocity less, we are going to get a less frictional force here. Okay? Now let us refer the design data handbook. Let us refer the design data handbook. That is what figure number 15.1. Now refer design data handbook. Refer figure number 5.1. Okay. You have a diagram for Newton's law of viscous flow. One is what a fixed surface, another one is a moving surface. Okay. Now this is what a condition of your fluid medium. So before the application of velocity, now H is what a thickness of fluid film. F is a force. Now if we consider a distance y from the bottom surface, okay, now the rate of change of velocity is different at this location here. Okay. Let us take this is a small y, okay, and this upper surface is subjected to the capital V velocity. Now if you consider the triangle, I'll just draw a triangle here. Okay. Now this is what EF, this is V, now this is what H here. Okay. And if you consider a small distance from your fixed plate, it's what small v. Okay. Now in this case, F is a force, okay, capital V is velocity, this is what meter per second, this is Newton, okay. And consider a unit area as a, okay, and H as a film thickness, H as film thickness. Now let us take this film thickness in mm. Let us take this film thickness in mm. Okay. Now, based on the definition of Newton's law of viscous flow, the shear strength or the shear stress is directly proportional to the rate of change of velocity. that is what dV by dy. Okay. Now consider an constant here, that is what Z. Z is the absolute viscosity. Z is what? Absolute viscosity. Okay. Let us notify this as equation number 1. Okay. Now, in general, we are going to define the stress as what? As the force by area. In general, we are going to define the stress is what? Force by area. Okay. Now let us notify this as equation number 2. Now by equation number 1 and 2. So what will get? The shear stress tau is F by A or Z into dV by dy. Okay. That is what? Velocity gradient or rate of change of velocity. Now if you look at the rate of change of velocity or the velocity gradient or rate of shear, now it is not looking a little constant from the triangle here. That is what? If we take the value of dV by dy is equal to what? V by y is equal to what? Capital V by H. Now if you substitute the, let us notify this as equation number 3. Okay. Now if you substitute the value of dV by dy in equation number 3, now the shear stress is what? Z into V by H, okay, divided by 1000. Okay. Divided by 1000. So we are going to get this in is what? Newton per meter square. Newton per meter square. So now this is what? Equation number 4. You can obtain this equation from design data handbook. That is what? Equation number 15.1b. Okay. Now this equation is 15.1a. This equation is 15.1a. Now by this equation you can calculate the absolute viscosity if they have provided the shear stress, velocity as well as thickness of film, or you can calculate the vice versa, which one is a given value. You can based on the given data, so you can calculate the required parameter. Now let's go for one more viscosity. That is what kinematic viscosity. Now this kinematic viscosity is noted than Z dash here. Sorry, ZK. This is noted with letter ZK. Okay. According to data handbook, it has been noted as a Z specific K. Now this is defined as the ratio of absolute viscosity to mass density of that fluid. It is defined as the ratio of absolute viscosity to mass density of fluid. Now this is what Zk equal to Z divided by rho into 10 to the power of minus 3. Now rho is what? It is the specific gravity of the oil. This is specific gravity of oil or fluid. For this one, you refer design data and book equation number 15.2a. Now, since the most widely used unit of measurement of viscosity is in centistokes, so most used unit of viscosity is what? Centistokes. Okay. Now, to get the value of centistokes, can use equation number 15.2b is what? Zk equal to Zk dash into 10 to the power of minus 6. This is what? 15.2b. Okay. Or you can use equation number you can use equation number 15.2b with two units here. One is centipoise, another one is centistokes. Now above equation is also good to calculate in terms of centistokes if it is a dynamic let us see how we can calculate it. Z is what? A centipoise divided by rho. Now you are going to get a centistokes here. That is what? If the absolute viscosity in centipoise, you can calculate the kinetic viscosity in centistokes. Now this is what about viscosity.